Welcome to Earth Science, everybody. We're going to look at the paths that hurricanes take. Speaking broadly, the way that many of them work is that they tend to take this path right up to about there, and then they make a curve. Is that true for every single hurricane ever in the history of man? No. Is it the general pattern? Yeah, seems to be. Look at all of these. They come up around that somewhere around where Florida and Georgia meets, and then they take a curve. They come up to around there, they take a curve. It kind of seems to be how it works. And again, depending on how weather's chaotic, depending on how systems go, maybe that changes. I don't know what's going on there. Fun but fake hurricane spaghetti model. There you go. That's fake. In general, they curve up towards there, and then they head out to sea. There's another one. They're all over the place. Although this is on Facebook, I'll still confirm that this looks about right. Okay. So they call these spaghetti models because they look like these thin strands, are all showing us the general flow of how hurricanes work. That is guided by, broadly, again, by these wind belts. Now, you should have already made it through a lesson on wind belts. In fact, we could point exactly to the lesson. If you haven't done it yet, please make sure that you've done lesson M before you do this lab. Otherwise, it's kind of confusing. Okay. We're going to do a lab in which we track hurricanes. So what are they? Hurricanes are large, low pressure centers. Lows, those are storms. Highs, nice and dry, clear, blue skies. Anything that's associated with bad weather is going to be low pressure systems. They strengthen. This is going to be the answer to some questions later. They strengthen thanks to the evaporation of warm ocean water. When that happens, that's basically like their fuel. If you want to think about that in a complicated sense, it has to do with evaporation and what that does energy wise. But let's keep it simple. Let's not get there. Evaporating warm water powers hurricanes. So what happens when they're not over evaporating warm water anymore? Like when they hit land, they weaken. That's going to be it. Since this is their source of fuel, they begin to weaken once they hit land. That will get you to some questions at the bottom, I promise. To understand how they move and why they do that funny curve thing, which is kind of the point of this lab, we must look at global wind belts, which again, lesson M should be done first. Okay. So first off, hurricanes rarely form within, roughly 10 degrees the equator. That gets complicated with how the Earth is spinning and the difference in Coriolis effect near the equator. They tend not to happen right near there. So they'll form off that a little bit. Now things are all opposite in the southern hemisphere. We're going to ignore that. We live in the northern hemisphere. That's what we're going to study. Because of their own spinning, they're low pressure centers. Can we go back to our meteorology cheat sheets and remember which way lows should spin here in the northern hemisphere? Can you? Counterclockwise. Because of their own spinning and the Coriolis effect, there's a natural way in which they get sucked towards the poles. They want to go towards the poles roughly. And if all of this were true and the Earth were not spinning, we would say that they form somewhere around here and they would want to go pretty much up towards the poles. But the Earth is spinning, and that is why as they head poleward, they're not going to go towards the equator. As they go poleward, they're stuck in this wind belt right here, the northeast trades. So what happens is that as they form, they get blown that way. And then they get to 30 degrees here, and suddenly they get caught in that wind belt, and they get pushed back that way. So see that pattern right there? Off towards the left, then off towards the right. Again, hurricane on its own wants to go up towards the pole. That way for a bit in that wind belt, that way for a bit in that wind belt. That's it. Their movement is influenced by the wind belts. Note the difference at 30 degrees north. As it switches from going that way towards going that way because it's influenced by these arrows. And again, the overall flow is that it wants to go northward. That's why it can go like against the winds here. It goes against the winds, but still gets influenced them and shoved off there towards the west crosses 30, and then boom, gets shoved back over towards the east, which is why they all kind of look like that. Now, that 30 degrees, remember that can go up and down a little bit with the seasons. Don't panic about it being precisely 30. It's around there that the hurricane would leave one wind belt and enter the next one, giving us that broad curve. That's the point of this lab. The questions at the bottom are going to come back to that a couple of times. They spin counterclockwise, they go that way, and then that way, and it's because of global wind belts. And that will be there too, why they're powered. So here's the job on this lab. It says using pencil, but you're here in Cami, you're going to use dots. I said Katrina's going to be blue dots, Irene's going to be red dots. And I say that because I already started some of them for you. I know that latitude and longitude's been a little slow. So I did the first 4 points on each hurricane for you, at least to get a start. 1, 2, 3, 4 are done on each one. I did these in size 4. That's what I recommend. When you make a dot, do size 4. When you do a dot, that one's wrong, but it'll be about that big. Get it as close as you can, but we can't take a week with this. This has to be like boom, 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 plot these things out. And all we're going to notice is that right around 30, we should see. In fact, you know what we're going to do? Here's what I'd like you to do. Grab a color that's not red or green because you're already using those. Right around 30, let's like highlight that line with a nice, perfectly straight line like that. It might be wiser to make it thin or to make it slightly transparent. I'm going to do both. And yes, I know there's a line tool. If you're comfortable using that, go ahead and use it. Right around there is where we're expecting these hurricanes to change direction from us as amateur meteorologists here in neuroscience. So we're going to see this hurricane go that way, get to there, boom, bounce back. This hurricane go that way, get to there, and boom, bounce back. That's it. Plot them quickly. Don't delay. Get it done. The next step says to plot out, to graph the wind speeds and pressures to compare them. So we're going to pretend magically you did that. Boom, you did it. Really, I did it for you to just try to make this thing go faster and smoother. So you're going to compare in this one hurricane what happened to air pressure as the storm passed, as the storm strengthened. The air pressure does this, and at the same time, the winds do that. Can you tell me that in words? Like, what is the relationship between pressure and wind speed? What seems to happen as it dropped? What seems to happen as it rose? What happened to the wind speed when the hurricane was over land? You're going to see it. As soon as this, by the way, we plotted the blue one. As soon as, of course, I did it in red. Beautiful. As soon as it gets to land, that's going to be right around here, where you're going to see the wind speed drop back off and the pressure came back up. So the graphing's all done for you. I want you to figure out these couple of questions. It shouldn't be too bad. Use the data, use the blurbs at the top, couple of regions questions, and you're out of here. I think that is a 40-minute lab. Maybe we stretch it out and we do it like a little bit more than that, but if we're going to get through all of these, let's do it. Get this done and move on to the next one. Okay? Thanks, everybody. I'm with you, and again, I'm trying to help you out. I did that graph for you. I gave you your first couple of points. I'm trying to like make this as smooth as possible to wrap this marking period up. Join me. Punch through that data. Get some latitudes and longitudes done, and you're out of here. Thanks. Good luck.